So welcome everybody. With the CAD, I'm just opening up some files here and I will present. So we're in onShape and most of you have gotten that. We've got a couple new people. So if you're new, just don't worry. You're probably gonna be a little bit overwhelmed. That's why I'm recording it. You can go back to it. And I just want to do a quick check. Remember for everybody that there's the Learning Center. And in the Learning Center, there is the fundamentals. So that's just loading up. So if you go into the Learning Center in onShape, there's the onShape fundamentals. And my expectation is that you work through this on your own. It will make it much easier to do CAD if you've gone through this. So that training, take your time to work through it and stuff. And right now I'm going to start here. I've just created a folder. And depending on where you're at, you might want to try to follow along as we go. I'm going to go pretty fast today. So if you find it overwhelming, remember that I'm recording it. So you can just watch to just kind of, okay, how's that done and stuff, because you can go back to the recording later. So that's a key thing. So here is the little presentation. So we're going to CAD a drivetrain. It's October 19th. As always, thank you to our sponsors. And I just saw this joke and I just had to throw it in. We believe we now have a consensus on the CAD standards. Sam and I have had lots of debates over the years about what we should have, what we shouldn't have and stuff. And it's always evolving. Now, drivetrain's the most important thing. Having said that, it's also in some ways the simplest thing. And the reason it's the simplest is because it's so important. I don't want to mess around with it. So, like for example, we're trying to raise money to do a swerve robot. We are not going to do swerve in competition until we've built one outside of competition and practiced with it and tested it. So once January 6th or January 8th comes along and we have our game, if we think, hey, swerve would be really great, if we haven't built one before then, we're not doing it. I want to make sure that with our drivetrain, it's reliable and everything. So weighted objective tables are really, really important. And this link, and I'm just going to, with the recording, all of this will, if you go to your Google Calendar later on, this will all be saved there. So you'll be able to access the links and everything in the Google Calendar. So there's the weighted objectives table. And I'm not going to read it, but it basically, you look at what criteria you have. So for me, cost, experience, reliability, maneuverability, and you weight those different things. So even though swerve, for example, is very maneuverable, it comes at a very high cost. And once we do the calculations at the moment, it's not worth it to us. Now, if we get those swerve modules, if we raise the money to do that, and we build a test robot and stuff, well, we can use those same modules. Now the cost drops down. All of a sudden it becomes feasible. So basically, this is one of those decisions. With design, we need to be able to take our ideas and focus on the quantitative data and make decisions based on that. So that's one way that we do it. And there's two key systems that we're looking at: the kit of parts drivetrain and the West Coast drivetrain. And I'm actually going to CAD both of them, and I'll show you in a bit. So first thing is, we're going to look at the dimensions. So infinite recharge, these were the dimensions of our robot, 32 inches by 27 inches. And I'm going to use that as my starting point. So I'm just going to quickly escape out of this. Let's just put that and go into my documents. So in my documents, I'm going to create a new document. And the naming conventions are really, really crucial. So if you're on the drivetrain team, there is basically we're going to have a different document for each section of the robot. So the overall document is going to be something like this. So it'll be 4152, that's our team number. And then it will be our team name, the robot name. So for this is OCT 21. So this is our October 21 robot. For competition robots, we reserve the year for competition. So when we do competition, it'll be 415222 because it'll be the 2022 season. And then A for assembly and 00 robot. So this is the first file. So this is the master file. Myself, David, Sam, those are the only people that should be manipulating this file. And this, we basically don't touch. The idea with this is that this is the overall robot. And when you're working on something, you're going to work on a subsystem of the robot. So there's my overall robot. That's great. I'm going to go back into onShape. And now my next file is automatically going to be my drivetrain. So 4152 OCT 21A01. So each subsystem, 00 is the whole robot, 01 is the drivetrain, 02 is the gearbox, 03, and we make a decision early on with what each subsystem is, and that's how we do it. So this is the drivetrain, and I might put our team number as a label or something like that so it's easy to find. Okay, so here's the drivetrain. We're going to start with the sketch, and basically we're just going to pick the top view. And for those of you that are fairly new to onShape, I'm gonna go over this really fast, and the whole point is you go through the learning pathway so that you get comfortable with this. But basically, here's my tab manager, and right now I've only got two things. I've got a part studio and an assembly. So part studios allow me to design my parts, and assemblies allow me to put things together. And David's just got a point. Yeah, exactly. This naming convention, it can get really complicated. So when we're making parts, our robot will have thousands of parts, and having this sequential system is really, really important for us. So that's kind of a key thing. And the other key thing is by separating this into separate documents, we ran into a problem where it would just bog down because there was so much detail. So by separating the documents, this is new for us this year. It'll allow, let's say David's working on the drivetrain, and Avalon's working on an intake, and Sophia is working on a climber, and all the different people are working on different parts. And because they're working in different documents, it's not bogging down the same way. So that's going to be a really key piece. So the tab manager, I'm just going to hide that so I can see my screen. There's my top view. And again, if you're new, you have this little cube here, which allows you to look at things in 3 dimensions. Your right mouse button allows you to rotate your camera. Your scroll wheel allows you to pan the camera. Your scroll wheel allows you to zoom in and out, and your left allows you to select. So top view, sketch. And whenever you go into a sketch, again, you N to normalize. And what I mean by that is you type the letter N to normalize it. So here is my view. And as I mentioned, I'm going to have a drivetrain. So what I'm going to do is I'm just going to create a center point rectangle. I'm going to click on the center. And as you're using onShape, the orange indicates that there's a constraint. So this particular constraint, if you see the little symbol, that's the symbol, and it's the coincident constraint. And when you hold your mouse over something, it tells you what it is. So they share the same location. So basically that means that the center of this rectangle is going to be locked on the origin, which is what I want. So I'm going to click and drag, and you'll notice I'm making sure that I'm not getting any orange, and I'm just going to click over here, and now hands off the keyboard, and I type. So my width was going to be 27. I'm going to make a change. What I'm going to do is I'm going to type the number sign. This is new. when I type the number sign, I can create a variable right in here. And I'm going to call this robot width. So, and I'm going to hit enter. And here I'm going to type 27. I'm going to stick to numbers instead of length. And the reason I'm going to stick to a number is because as I manipulate things, if it's a number, I can do math with it. And if it's a length, I can't. So I like using numbers. And so that's going to be 27. Click the little green check mark, click enter. There's 27. And then same thing. Whoops, I don't know what happened there. So I'm just going to hit escape and click my dimension tool. So that's my dimension tool. Click, click, and again, I can create a variable right in here. So this is going to be my robot length. And this was 32. And enter. And now there's that's the perimeter of my robot. So I'm just going to click the green check mark. I just want to explain a few things. So the first thing is you can see my variables are right there. And this is a fairly new feature. So those of you that did Techno Girls, we may not have dealt with that back then because it wasn't part of OnShape back then. So it's a really useful feature. And I can click in here and you can see I can type a different number. And everything is automatically adjusted based on the number that I have. So there we go, 27 by 32, that's the perimeter that I'm going to use. Now, I'm going to just quickly, how do we get that? And there's a couple key aspects. Aspect number one, read the manual. This is going to be something you're going to hear from me over and over again. But this is the link to the FIRST Robotics competition manual, and firstinspires.org. That is the website for FIRST Robotics. And that is a website that we use to find out the rules of the game and stuff. And it's going to be really important that everybody is able to go to that website, find the manual, and read through it. So there's the links for the manual, and you can see there's a bunch of, no, you can't see on that one. So let me just skip over to, I've got the page open. So here's the manual, and you can see there's different sections, and the section on robot construction, that's going to be crucial for the design team to know about. And in the robot construction, you can see here is a rule, R3, your perimeter cannot be greater than 120 inches. So our robot is 27 inches by 32 inches. If you do the math, it's going to be under 120. And it can be no more than 45 inches tall, and we can't extend. So that was the rules for infinite recharge. The rules will be different, but typically what we've found in the past is that the kit of parts drivetrain is basically a 32-inch long side. And so that seems to work really well. So we try to stick within that. Having said that, I've made a 24-inch robot last spring and this fall. And if things work well with this, then that might be something that we would look at if there was a game where we had to balance with other robots. Well, having a smaller robot's going to be a huge advantage because you could get more robots on. So there's our sketch. And over here in the feature tree, it's really important. You can see all your different features, and you can double click to go back into the sketch. So I'm in the sketch, and that's my perimeter. So I'm going to now start doing some rectangles. So instead of the center point, I'm going to click the drop down, and I'm going to select the corner rectangle. And what I'm doing here is I'm going to click, we're going to use 1x2 tubing to create this. So I'm going to click on that corner. I'm going to move my mouse over here, and I'm going to click, and I'm just going to hit escape because I don't want to over constrain. And let me show you what I mean by that. If I set that as 27 inches, let me just do it again. you'll see what I mean. So that orange indicates that it's going to have to touch that. Well, if I then set the width, this is over constrained, because what's going to happen is it's saying, hey, you're saying that this dot has to be touching here and this dot has to be touching here, and you're saying this has to be 27. Well, they're going, what if you change the width? Then it's not going to be true. And what do I pay attention to? So that's why I don't want to set that distance. Anything in red is bad. So what I want is the black line. So here's the blue line. It's not constrained. My dimension tool, and you'll notice that when I hold my mouse over a tool, there's the letter D. Using keyboard shortcuts, so the letter D turns the dimension tool on and off. Get comfortable with those because it'll make you faster. So I'm going to click that line and that line with my dimension tool, and I'm just going to say this is going to be a 1 inch. So we're using 1 inch by 2 inch tubing for this. So that's 1 inch. And then I'm going to create, what I want to do is I want to have another one over here. And this is where I'm going to take advantage of the mirror tool. So the mirror tool allows me to select this line right here that goes through the origin and select this line. And just like that, I've created another rectangle at the bottom by mirroring it. And one more rectangle over here. So this is going to be my side rail. And you'll notice that I've just put it in a little bit. I am going to make it 1 inch, but I'm going to escape. I don't want to set that height. Now, this particular one, what I need is I need my wheel depth, and I'm going to use a variable. So my dimension tool, I'm going to click this line right here, and I'm going to click this line right here, and click and type. And by typing the number sign, I can create a variable. And so what I'm going to call this, it's going to be a number, wheel depth, and it's going to be a value of 4. And click OK. So the idea with the West Coast drive is my front will actually extend past my wheel, and I'll have my wheel in here on an axle. So that's all good. Again, I want to mirror it. So I'm going to click the mirror tool, click that line, and now I can select those lines, and there's my frame perimeter. That's what it's going to look like. So that's my sketch, and I like naming things because we're working as a team. So naming it sketch geometry, that kind of makes sense for our sketch perimeter. It's a little easier for us to figure out what you're referring to. And you'll notice that in here, you can actually add folders and organize the features. Sam does that. It makes it so much easier because we're going to have so much stuff. Now, let's go back to the slideshow. Wheels. So with wheels, we need to make some decisions about our wheels. And there's a whole bunch of different options. I am just going to share this link with you. Copy link address. This is a phenomenal resource that NASA and the Robotics Alliance project put together. It's a robotics design guide, and basically they go over everything. And you know, why would you use a 4-inch wheel versus a 6-inch wheel? There's a lot of detail in this, and it's really worthwhile reading. So there's some advantages and disadvantages. So infinite recharge, for example, there's a bump on the playing field. So the question is, we need to get over that bump. And right off the bat, that kind of eliminated 4-inch wheels for us, because the 4-inch wheel wouldn't get us over that bump. Now, some teams did a 4-inch wheel, and what they did is they kind of built a ramp so that their wheel, there was a little ramp so it would actually slide up, but they had to put their wheels close together so that it wouldn't get caught on the thing. So there's ways around it, but immediately a 6-inch wheel worked, so that's what we went with. There's also other options. So a pneumatic wheel, if you're trying to go over really bumpy terrain, a pneumatic wheel is like a tire. That might be really worthwhile. And if it's really flat, then a little 4-inch wheel, so you're low to the ground and really quick, can be the way to go. So advantages, disadvantages, et cetera, et cetera. I've already talked about our numbering system. I'm going to skip past that. And belts and pulleys. Okay, so we've got to decide on a wheel. Right now, I'm just going to stick with the 4-inch wheel. And there are different belts and pulleys. So these are some of our options that we can use. And I'm just going to explain some of them, but let's go back here because right now we just have a 2-dimensional sketch. So let's turn this into an actual shape. So now over here, you can add custom features. So if you can't find the custom features, if you're looking on a smaller screen, the search tools is always at the end, and you can just type custom and there's add custom features. So when you add custom features, these are some of the things that they're called feature scripts. And the idea is that somebody has programmed a whole sequence of steps. So some of this stuff would take a long time. By using this program, we can do it really quickly. So the one that I'm going to use is called Extrude Individual. So what you do is you just type Extrude Individual. And I'm going to copy that and put that in the chat. So if spelling is not your strong suit, and there it is. And when you hold your mouse over it, if there's a bunch of different ones, this is the one from Julia's feature script. So that's great. So that's what we're going to use. You would click on it. Now I'm not, because I've already got it. So these are all the custom features that I've added to my onShape. So there's Extrude Individual. I'm going to click on that right now. And what I can do is I can click on each of these rectangles. And I'm going to set my depth to 2 inches. And Extrude Individual, I call them rails, and green check mark. And just like that, I have 4 different parts. You can see I can hide each of the individual parts down here. And I actually have some rectangles now. So that's kind of cool. Now, what I'm going to do is I'm just going to turn to the right. And what I'm going to do is I'm going to click on the right plane and I'm going to create a sketch. And what we're going to do is we're going to set where the wheels go. So the first thing is we're going to create a circle here and we're going to create a construction circle. So this is just going to show us where the wheels are, and I'll explain what we're doing in a moment. So what I do is I've got my circle tool, my construction tool, and now I'm going to hold my mouse over the origin, and you'll notice there's a little orange dotted line that indicates this is vertical to the origin. So that's great. I'm just going to click somewhere and click and type the number 4. So there is my 4-inch wheel. Now, what we want is we want a drop center. And a drop center means that this is a 2-inch. So what we're going to do is we're going to click the dimension tool. We're going to click the center of the circle and the origin. And over here, we are going to click. So half of 2 inches is 1. And what we're going to do is we're going to say this is going to be 1 minus 1/16. 1 minus 1/16. So what that does is that the center is just 1/16 lower than the middle. And the reason for that is we are going to use a 1/8 inch drop center. And the reason we're doing the drop center is as our robot is driving along, if all 3 wheels are touching the ground, that's a lot of friction when I'm trying to turn. So by having the middle wheel just a little bit lower, 1/8 of an inch, then basically only 2 pairs of wheels will be touching the ground when I turn. And that reduces my friction. So it makes it easier to turn. And so there's my drop center. And what I'm going to do is I'm going to create another circle here for the front. And I'm just going to click somewhere over here. And you'll notice I'm clicking way up here, and I'm going to explain why. And I'm not going to set the diameter. What I'm going to use is my equals constraint, and the letter E allows you to do the equals constraint. And I'm going to click the two circles, and now they are equal in size. And so if I decide, oh, 4 inches, we did some testing, that's not going to work, I'm going to use 6 inches, then I only need to change one value for the 6. And I could make that a variable. There's lots of ways that I can do this. Now, the reason that I'm doing this is because I need to set 2 dimensions for this. So the first dimension, I'm going to click my dimension tool, and I'm going to click the center of the one circle and the center of the other. And you'll notice where I hold my mouse will determine. So right now, that's horizontal, that's center to center angle, and that is vertical. So I want the angle. And this is why I made it up here, is because it's easier to get the angle measurement. So there's, when I've got my angle measurement, I'm going to click, and I'm going to create a new variable. So number sign, new variable. And this variable is going to be a number, and it's going to be called C to C. That's short for center to center. And right now, I'm just going to set this to 5. It can be anything you want. And check mark. There we go. The reason we're doing this is because I'm going to have my wheels, and I need a belt to connect the pulleys that are turning these wheels. And the center to center is going to be really, it needs to be a really exact number. And so I want it as a variable so I can set it. So, okay, so the next variable, the next dimension that I need, again, I click the 2 centers, but this time I'm going for the vertical. And what I'm doing for the vertical is this is 1/8 of an inch. So now you can see this center is just a little bit higher than this center. But that's why I do it that way, because it makes it much easier to get that diagonal first. Okay, so I've got this value. Now my center to center right now, 5. Let's try 10 inches. And what I'm looking at is I'm looking at where does this wheel go? So right now, 10 inches seems to be, okay, 12 inches is pretty close to the edge. So perfect. So that's that's what I'm aiming for. And the reason I need to know that is I need to make some decisions. So back to the slideshow. Here's my decisions. I need belts and pulleys. And basically, we have a couple of options. Now, with the kit of parts, we get 42 teeth pulleys. So I have a ton of 42 teeth pulleys. So that is an option because we already have them. The second option is Sam has done a West Coast drive, which is phenomenal. This is what this is based on. And basically, he's designed his own 30 teeth pulleys, which work really well. And there's Sam. Go for it, Sam. I can't hear you, Sam.
Hello.
There we go.
So the biggest thing I'll mention about the pulley I design, I do not know how the hub of it will hold up to FRC robots because it's 3D printed. I just want a disclaimer that it might not hold up. There are ways to remedy that, but that requires us to either buy something or make something to solve it. So,
yeah. So, and that's where this is why we've built one of these right now, and we're going to drive the heck out of it and see how well it holds up. And if it holds up well, great, we're going to use that. And if it doesn't, then we stick to the 42 teeth. So, awesome. So those are our options, and these are HTD. So I got a couple links on here. The first one is West Coast Products, and they have a belt calculator. So we can do all the math here, which is great. And I'm just posting the link in the chat for that. And the second one is Vex Robotics. Vex Robotics is where we buy most of our belts and pulleys. So if you're doing a design, what you want to do is make sure that it matches a belt that they have. So here is the West Coast products, and there's a couple things. So the first thing is, I mentioned in the slideshow that we are dealing with, oops, where did the slideshow go? We're dealing with a Htd pulley. So an Htd pulley has a pitch of 5 millimeters. And so when you have a pulley, you have teeth, and the pitch determines how far apart the teeth are. And David, bang on. This is really crucial stuff. We stick with inches because so many of our items are inches, but you'll see when we buy belts and pulleys, they're in millimeters. And that's okay. So in here, pulley number one, let's say we're doing the 42 teeth and the other 42 teeth, and we could obviously use the 30 tooth instead. What we have here is we can set our desired center. So when we looked at our design, we had decided a center to center of 12 inches seems to work. So we're going to say we want 12 inches. And down here, this tells you these are the belts that are close to 12 inches based on those pulleys. All it is math. It's circles. It's really neat math calculations, but they've done the legwork for us. So there's our center to center distance. So what we'll do is we will type that in, and it is a desired belt of 160. So the first thing is talk to me. At some point, I'll share with you the inventory that we have. We've got a whole bunch of belts. I've inventoried them. So the first thing is to look at, do we already have something so it'll make it quick and easy to use? And if not, then how much does it cost to buy? So if we can make decisions based on stuff we already have, it makes it a lot easier. I do like using new belts for competition because they're not worn down. It's just a lot easier. So there we go. Our center to center and our wheel is automatically set up. So that's great. And I think you'll notice that there's the desired belt. We'll be getting to that in a moment. So we'll just keep that open. And what we're going to do now is go back into this sketch. So that was called sketch 1. And what I'm going to do is call it sketch bearing holes. There we go. And what I'm going to do now is I'm going to create a circle. And this time I'm going to create a circle based on the center. And 1.125 is the size of our bearings. But what I want you to do is do the plus and new variable. And we're going to call this variable offset. Every single sketch that we have, I want, when you're doing holes for bearings, I want offsets included in them. And the offset for this, we're actually going to leave at 0 for now. But this allows me, when we're doing something on the CNC machine, we can set the offsets. We can do a test cut and go, okay, we need an offset of this so that it fits perfectly. That gives us that flexibility. So same thing over here. You'll notice I'm zooming in, so I'm getting the center. And I'm not setting the value. I'm using the equal sign to set equal to the bearing hole. And again, I'm going to use my mirror tool to mirror that. So there's my 3 circles. There's my bearings, sketch my bearing holes. And what I'm really want to focus on, how do we save time? So I don't even need to save the sketch. I can go right into Extrude. And with the Extrude, I'm going to remove, and I'm going to remove through all. So what that will do is that's going to remove through all, and you'll see it's merging with this part. Well, I got to select That's not the part. I'm just going to click that. There we go. So it's merging and it's going through there. And what I want to do is I also, I want to go symmetric. So it's merging through both pieces. And that's my extrude, my bearing holes. There we go. So now I have my bearing holes. And what I'm going to do now is I'm going to turn this into tubing. So there's another feature script. So again, custom feature, remember. So there's my custom features. And this one is called tube converter. And I'm just going to type that in there. And again, Julia's feature script. She's got a whole bunch of these. So you click it. If you watch what I'm doing, I'm just going to do it really quickly. So tube converter. And what I'm going to do is I'm going to select all 4 parts. And whoops. It takes a few moments to do it. So just be patient. And I've got my wall thickness, 1/16 of an inch. That's great. I am going to exclude these faces. And I'm going to right click and just get that face too, and that face. And the reason I'm excluding those faces is we don't tend to put holes on that. As we're doing the design, we can debate that. It might be really worthwhile in terms of mounting the bumpers and stuff like that. But just for today's demonstration, I'm not worrying about it. And there we go. I've got my tube, and you can see my parts are listed, and the names are, I like how they've set it up. The names make a lot of sense. That's just great. So one other feature that I'm going to do, you'll see I'm selecting all of them. And by selecting all of them, I can go right in and just right click. And I can go into my properties, and I'm going to set my part number, 4152 OCT21. Now, key, because this is going to be a part, 01, and then I'm going to number each of them. So what I can do now is I can click on just the first one and set it as number 1, click the second one, number 2, third one, number 3. And just like that, I've got unique part numbers for all of my parts. I've got, if I need to buy them from somewhere, I can put that in right off the bat. We buy our aluminum tube from Reynolds. And I can apply that and save that, and I'm good to go. So I've got my part numbers. I'm good. Now, we've got that designed. Might as well design our L brackets while we're at it. And what was my wheel depth? This should be lined up. I'm not sure why that's not lined up. Give me 1 second. Go back into sketch geometry. That's because this distance I never set. I wanted it to be wheel depth. Don't know what happened there. It's just got to regenerate everything, which will take a second. There we go. So everything's lined up. That's perfect. Now, actually, no, I'm not going to design those. Just give me 1 second. Okay, so we have this. We have our basic drivetrain. I'm going to go over to assembly 1 now. And I'm just going to insert. And I can insert the whole part studio. Green check mark. And I'm going to right click and make sure I fix. And to be honest, for these particular ones, I'm just going to fix all of them, just lock them in place. That's not, I like to make things, but my goal with this is to get things done really fast, because we want to start manufacturing as quickly as we can. So if we can design it in the exact location, then we can just fix it in place and we don't have to mess with it. We do want to do mates later on and stuff, so that's going to be handy. Okay, now, the reason I wanted to go into the assembly is with the assembly, I have this button, which might be new for some of you, which is called Create Part Studio in Context. And this is really, really handy. So what I'm going to do is I'm going to click that and I'm going to select the origin. And I have yet to come across a reason why I would select another point. I know that there is a rationale, but I haven't needed it. So green check mark, so we just select the origin. And what this does is this creates a new part studio, but we can see this. So it makes it really easy for us to design based on where things are. So I'm gonna just zoom in here. I'm gonna click on that face and I'm gonna click sketch. And this is where it's a little tricky. So watch what I'm doing. What I'm doing is I'm gonna right click this line and select other. And this allows me to choose what I'm selecting. So I'm going to select the edge and I'm going to select use. So the letter U allows me to quickly select that. So I'm going to do the same thing, edge of context. Now this one, because it's not the context, it's easy for me to select. So I'm just going to select them and use. And what I've got now is I've got these lines and I'm gonna add my circles, and this is where again it's a little tricky. So the select other, selecting the edge allows me to select the edge. So it's a little finicky with that, and you just need to know that and remember that it's a right click to be able to select other, so that you can pick which thing you're selecting. These, because it's not purple like that, then it's not a problem. The purple indicates that's the face that I'm using to make all my calculations from. Okay, so there's my 3 dots. There's my stuff. I've got a line here, so I'm just going to create, whoops, Control Z. I'm gonna create a vertical line right there. L turns my line tool on and off, so I can quickly create a T bracket. There we go. So there's my T bracket. I just need to set my distance. So that's going to be 1/2 inch from there. That's going to be 1/2 inch from there. Oops. And that is going to be 1/2 inch from there. And Sam's got a lot of really good techniques with this stuff. So if he shows you something and it's different than mine, like there's more than one way to do stuff. So take advantage of those ways. Okay, so there's my sketch, T-gusset. Okay. And now that I've got my sketch, I can extrude it, and basically it's going to be 1/8 of an inch. I like right clicking to make sure I'm going in the right direction. That looks good. That looks good. Now the biggest thing is that I'm going to use the Fillet Tool, and I'm going to set my radius 1/4 of an inch, which is 0.125. And the reason is that we would cut this out with the 1/4 inch bit. So it will fit nicely in there and just make it easier to manufacture it. So there we go. There's my T-gusset. So I'm getting these corners. You'll notice that I'm doing these corners. It's a piece of flat aluminum that this is going to be made out of. And I'm not doing the top. I'm not going to round it over like that. I'm just going to get those corners for cutting it. So there's that. I've got my part. I would name it. I'm going to try to speed up. So I'm just going to insert and go to assembly. And there's the part. What we can do, let's just, what I am going to do is I'm going to add a Fasten Mate. I'm just going to try something. What I'm doing is I'm just going to try to fasten it to that. And I'm going to select the center of that. And that kind of works. And then I can just offset it from the edge. 4 inches was too much. 3 inches is what I need. And like that. And the reason I'm doing that is that way, if we change our distance, change our holes, then it's not going to be offset. It's going to be set based on that distance. So that's going to be a key thing. Now, I'm going to just try something. I don't know if this is going to work. Let me just try this. Yeah, it's not going to work. Anyways, I've got that particular part. I would obviously add a gusset to each corner, but I'm looking at the time and I got to speed up a little bit. So I'm not going to bother. What I do want to show you is that when you have the gusset, so if you think about this, we have a 2-inch tube, we have an 1/8 inch gusset, and we would have another 1/8 inch gusset there. So that's 2 1/4 inches. So that tells me that if I'm going to use a bolt to secure this, it's got to be 2 1/2 inches. So that we've got some room for that. So what I'm going to do is I'm going to click the face of this and I'm going to click insert and standard content. This is ANSI. It is bolts and screws, and we use the socket head screws, socket head cap screw, and we try to stick to 1032, 2 1/2 inches, and insert. So I want you to always stick to 1032 and in 1/2 inch increments, and there better be a good reason to do something else. And there can be. So our intake, for example, we needed to make sure that the bolt heads weren't sticking up. So we did a V1 and we'd used Lexan. And so we countersunk them so that they were nice and smooth. So there is reason to do it. But the key thing is that whenever we're doing something like that, 2 1/2 inch, I've got them in stock, so we can just grab them and start making. If we're doing something special, I need to order them, and that takes time. And so we want to reduce time as much as possible. Now, on these corners, I want to show you, we use something called ThriftyBot. And ThriftyBot has a whole bunch of different items, but the items that I have bought are these bearing blocks. And so these bearing blocks are right there, and you can see they have a CAD model available. So you can download the ThriftyCat CAD model, and then in here we can insert. And whoops, I need to import it first. So down here, plus at the bottom, I'm going to import. And there's the CAD model. So I'm going through this really fast, I know. Those of you that have done this before, you shouldn't have too much trouble, but you might be rusty. You might need a little practice. So there we go. It's imported, and now I can insert it into my thing. And I don't know, there's not an assembly, unfortunately. So there's my bearing block. Now, with the bearing block, these are pretty cool. If you look at the diagram, you can see that the center, one side has a greater distance than the other. So we have the drop centers. So the shorter distance has got to be for the center wheel, and the longer distance. So this side looks to be the shorter distance. So what I'm going to do is I'm just going to fasten this. And fasten that center. And I'm going to fasten it to that center. And if it's like this, I can flip it around and rotate it. Let's just have a look at that. That looks to be the way it is. So you can play around with it and get it, but basically the idea is that will go in the center and stuff, and I'm good to go. Now with the bearing blocks, I also need to add a gearbox, and what I'm going to do is in the insert, go for it, Sam.
Are you planning to mention, just regarding clamping bearing blocks, are you going to mention the tensioner cams?
Not at this point, but we'll chat about that in a few moments. Yeah. Okay. Okay. With the bearing blocks, I'm just going to, what I need is I need a gearbox and CAD. So, sorry, you might have missed that. Let me just, so under insert, other documents, you'll notice that CAD is there. You can also search for the public. I have loaded, we have the enterprise version of onShape. So I've loaded CAD onto our system so that we have a copy of it. And I just find that really, really useful. And you'll see in CAD, there's a whole bunch of different things. And one of them, for example, is gearboxes. And there's gears. So there's gearboxes. And when you check the gearboxes, you can pick the assembly. And these are gearboxes that Vex Robotics sells, and Rev Robotics and that. So if Andy, Mark, we have the, Sam, off the top of your head, what was our shifting gearbox last year?
Should be a Vex.
I'm not.
Scroll up slowly. I might be able to see it.
It's not an EVO.
3-cent ball shifter.
That's it, eh?
Mm-hmm.
Okay,
no.
So this is what we bought last year. So I'm just going to click the assembly, and it's a fairly complex thing, so it's going to take a few moments. With the assemblies, you can see you can change the configurations and stuff. So we can do all of that stuff. So there's the gearbox. And the basic idea is that, okay, so here is the gearbox, and we need to mount that. You can see here's your output shaft. So this output shaft is what needs to get mounted through that circle. So I'm really simplifying this. You want to actually spend some time doing it, but to get through the time, I'm greatly speeding things up. So again, I'm going to offset it. I think I need to flip it around. And there we go. So I've got it mounted. And then the beauty is that these are your mounting holes, right? So now I can right click this part and I can edit in context. And I can select that. I'm going to do a sketch, and I'm going to select that hole and that hole and that hole, and rotate my view, get that hole, use them. And these are my gearbox mounting holes. And I'm going to extrude, and I'm going to remove through all. And just like that, my holes are there, done.
You'll probably want to switch that to symmetric in the future too, so that get them on both sides of the drivetrain.
Yeah, exactly. So that's how I can do it. And that's in my assembly. I obviously this assembly, not everything was mated because I've got this gear floating around now, and I need to make sure that this kind of thing can be a real pain. So when you see something floating around, figure out where it goes and get it mated in there so that it's not floating around. Now, with this, there's my bill of materials. And you can see what I'm going to do is I'm going to do structured. So instead of having every single component of the gearbox, I just have there's the gearbox. But I can quickly see these are the names, and I can click on something. Oh, that's my T-gusset. So I can change the name right here. And I can make sure that all my numbers are sequential. And so this is a part number from Thrifty. So I'm going to look it up, and there's the part number from them. And this is a really key thing. So I can't manipulate the MK CAD one, but it's grade. So it indicates to me, oh, this is something I buy. This is not one of these. So it tells me this is something that I buy. And you can see the socket head cap screw I've gone through and set from Fastenal. That's the particular thing and stuff. So it makes it easier when we're exporting this to make my shopping list and to make our manufacturing list. We have all the details that we need, and we've got everything. Now I'm going to switch back to my slideshow. Oh, the other thing is the JVN design calculator, and this is really a crucial thing. If you just do a search JVN design calculator, you'll find there's lots of links to it and stuff. And there's the latest version. So it's a spreadsheet. So what I'm going to do is just create a new sheet.
And just so you know, there's a copy of this on the team drive.
Yes. Yeah. We have a copy in the team drive. This is a really crucial aspect. So what I'm just going to open it up so I can explain it. Okay, so I'm going to insert by uploading. And the reason I'm uploading it is that I just want to have a fresh one because I play around with the drive one quite a bit. Okay, so there's a lot of information here, but the idea is that, okay, the Vex Pro 3 Sim ball shifter, in here, I can select my motor combination. And when I select my motor combination, you can see they've got sim options. We need to make sure that we always go in and add the Neo motors and the Talon FX. Go for it, Sam.
Again, so the one on the team drive,
It has those.
I've updated everything, so I got all the new motors are in the different files and stuff like that. So
Yep. Basically, I want to avoid using Sims. If I can use a Neil or a Falcon, Falcon, I would prefer that because they have built-in encoders. They're brushless. They have more torque. We've spent some money to get some, so we have some.
the other thing, the drop down. So under the second black box where it says choose motor pinions.
Yep.
So this is outdated. There is now a 10-tooth pinion option as well.
Okay.
So
you use the one
I've
from
also
Team
added
Drive.
that.
Yeah. So basically the idea here is that you pick your motors. Anything in pink you can modify. So if my wheels are 4 inches, great. If they're 6 inches, I can change that. Don't bother changing stuff like the coefficient and we always use the robot maximum weight as our guideline. But then you can start picking your gear ratios. And the whole point is that your gear ratio will determine what your speed is. So this particular setup, it's approximately 20 feet per second. If you look at Team 254, they have technical binders over the years, and it's really useful to read through those. And so you can see, oh, that game, they went for this many feet per second, and this game, they went slower. They're very strategic about what they do. So it's good to look at them to understand why you would pick a different speed. You can see your current draw, and basically the current draw gives us a clue on if this is going to work or not. And it's really, really useful to go through and be able to go, okay, we're doing a linear mechanism or an intake, and this can tell us how fast it's going to run and the stall, like if it's going to stall out. So that's a really useful thing. So if it's drawing 15 amps and we have it on a 40 amp circuit, no problem at all. So those are the key things that we want to make sure we understand. I am belts and pulleys, JVN design calculator. Oh, last one is belts. I'm going to just go over that quickly. So I have this in here, and I'm going to, right now I'm going to edit. No. Yes, I'm going to edit in context. So I'm going to right click this and I'm going to edit in context, new context. And what I want to do is I want to add a belt. And there's a feature script for it, of course. So there is one called the context-less belt. And I'm going to show you. So there's my bearing holes. So what I'm going to do is I'm going to set my pulley teeth. And we were dealing with 42 teeth pulleys, right? I think that's what we set it for. That's why my belt calculator, I did. So couple key things. Actually, before I go into this, let's just create a variable. Call it pulley teeth and set it a number 42. And the reason we're doing this is when you put it in the variable, if I'm like, oh, well, what pulleys do I need? I can look in the sketch and I can see, oh, pulley teeth. Okay, I know exactly. So having a variable like that makes it much easier for me when I'm doing my shopping and stuff. So now I've got that context less. I'm going to make my sketch for my bearing holes. And now for my pulley teeth, I'm just going to use that variable, 42. There's my pulley teeth. Now the pitch, remember, was 5 millimeters. And I'm going to select that point and that point. And just like that, we've now added a belt, and you can see that's a 162th belt, which matches the desired belt. And the bonus is that when we insert this in the thing, I should have all 4 belts in there. And I'm just going to, no, that didn't insert it. Whoops. I'm going to insert that belt. So I'm going to use the center of this and set it to the center of that. And I'm not, like, if you're designing a custom intake, then it's really useful to see if everything's going to fit and if the belt's going to rub against anything. But the bonus for me is that now in my bill of materials, I know that I need to have that size of belt, and I'm not guessing. And that's really crucial. I'm not spending time going like, oh, how big is this? What's this? So the more information I have, the easier it is to get the resources that we need. So we've got everything. So obviously this drivetrain is not done. There's a few missing pieces with it, but I think we've covered enough stuff to get you going on it. I want to show you one last thing. I'm going to create a new assembly. And if we decide to go with the kit of parts drivetrain, the beauty is that MK-CAD has that. So I can go to MK-CAD and I can look for the kit of parts chassis, and I can configure it 32, 72. I'm going to add a Falcon. Going to generate it, and just like that, I say just like that. Now I wait. Oh, I need to click that. Now that I've configured it, I click it and it's inserted. So we're at a stage, we've designed our drivetrain. Obviously it needs a little bit more work. But there we go. So I've got a couple of assemblies. I need to pick which assembly is going to be the actual one. I'm going to use this one, 45. So I'm going to give it the name. So anybody looking at this, the very first thing, that's the assembly that everything is based off of. I am going to now create a version for this. So I'm going to create a version 1. And the reason we create a version is now somebody else can come around and screw this up, and no problem, I can restore it. So that's a really useful thing. So I've created my version in my main robot. So there's my main robot. I can now open that up one. And I'm just going to fix that first tube in space so everything's locked in place. So now I've got my main robot, and somebody can go in here and they can create a sub-assembly and use this as reference geometry so that they can figure out where everything's going to fit, so that we can add our different mechanisms. So, all right, I've covered a lot of stuff. Really appreciate everybody's time. I want you to, if you have questions, either pop them in the chat or ask them now. If you are doing this on your own and want help, please reach out to Sam or myself or David. We're more than happy to help you with this because this is crucial. If I don't have your name in the attendance, let me get it. Make sure that you put your hours in.